In the last video, we saw the tensor score calculation, but we had lots of things that were not much needed at this point just for computing the tensor score. So just to understand attention score, I'm trying to remove some of the things that is not needed at this point. So for example, we don't need these imports. I will delete this cell. We don't even need the config tokenizer and these things at this point, just for understanding the attention score. We delete these as well. Even this is not needed, but we need the token IDs. So I will try to directly create a tensor having these values instead of this text. So what I can do, import torch and input IDs torch.tensor and this value. So if I print this, so if I run this one, we get the same values, same tensor, same input IDs. In this case, we just are not using any tokenizer for doing this step. We are just creating an array or a tensor with the same values whatever we had. So now we no longer need this one. We have already done the print. So even this cell can be deleted. This import is needed torch.nn because from nn this is neural network. From this we will have the bnn method that will do the matrix multiplication. So we'll keep this. Let me run this. Now here we need to do some changes. We are creating the embedding based on the config.vocab.size and config.hidden.size. We don't have config because we removed that import. That was the config for that particular model, but based on case that we were using. So in this case, what we can do is we can have some vocab size of our own. Let me create an error example. So if I give the vocab size as 10 and hidden size, this was our vector dimension. So last time it was 768. For this one, simplicity, let's create a vector of dimension 2. And this will be printed. Input IDs, now we don't have inputs, we directly have input IDs. So I will use this one. Just remove this inputs dot. Then yeah, this is doing this dot size, so this will work. Let me run and we will get to see some error. So this is index out of range in the self. Why it is happening is, so when we are giving vocab size as 10 in this place, so this embedding will try to check in the input. In this, the input should only have values from 0 to 9 because we are saying that vocab size is 10. So the input IDs is there between 0 till 9. That's why any values higher than that we are getting index out of range. So what is the highest value? This is the highest value. So if I use this, even this I will get because it is 0 index. So if I run this one again, taking the highest value, I'm still getting index out of range. But if I do a plus 1, so now we have 0 till 10029. So if I run now, this works. So it created the embedding. Then on doing token embedding with the input IDs, it generated a vector of this size 1 by 7 by 2, and this is the content. So for each of the token 101, 2051, 102029, all these, it created a embedding vector, and each of the embedding vector has dimension of 2. This is for the first one, first token. This is for the second token. This is for the third token. Likewise, rest of the code, I think there is no dependency with the other libraries, so I think it should run as it is. Let me run this. Here we define the query key and value, same as the input embeddings, and here we'll do the scores and softmax. And here it's actually a dot product, but we can see this BMM is doing a matrix multiplication, that is the cross product. How it works is, we take the query, we take the key we are doing transpose. So by doing a transpose, it actually becomes a dot product. How that can you visualize this? Let me show you in MS Paint. So this is the vector, and you can see the first vector is these two vectors. The first one is a normal, and this is the transposed one. So whatever was in the column became in the row. Whatever was same for the second one, whatever was the second column became the second row. Whatever was the third column, it became the third row. And in between these two vectors, if you do a cross product, so this 1 2 3, this 1 2 3 will get multiplied with this 1 2 3. So that is same as saying if this vector were also original without the transpose. So dot product between this and this. So that's how it is able to do a dot product by using the cross product function, the BMM, that is done at, at this point. Torch.bmm query and key it is doing transpose by changing the index or the this is the if you see the dimension of this one. Let me print the shape of this. Let me do this here itself. So if I do query dot shape and the transpose dot shape. So you can see the 1 and 2, it changed the indexes at 1 and 2. So it was 1 by 7 by 2, it became 1 by 2 by 7 by doing the transpose. And then the other steps will also be as it is running this functional softmax, and then this weights multiplication by the value vector. So in each of these cases, the size of the vector got reduced because initially we chose it to be two-dimensional. And just like the previous example, you can see after doing the softmax, if we try to add these values, it will be close to 1 for each of these. Let me take this example for. So this is coming close to 1, 1.001. So yeah, this is for this video.